Hello everyone, this is Muhammad Afifi from ConexTech. We are demoing today our latest technology, TCP M-Adaptive Transmission, the latest updates. We just dropped in an update. The setup we have is that we are connected to a Wi-Fi and the Wi-Fi signal is so bad we are away from the Wi-Fi. We are using a file sharing service called FileBin to observe the speed of the uploads and the progress. The kernel, the Linux kernel we are using is 6.14.0, which is one of the latest kernels and has all the updates to and upgrades to the TCP Cubic and Google BBR we are going to demo against. Now, TCP Cubic and Google BBR is a state-of-the-art algorithms which are widely used. For example, Cubic is used by Apple and Microsoft and bunch of other big tech companies and all over the world, while Google BBR is used by Google and Starlink in addition to other companies. They are making a big portion of the market today for the internet using TCP. So the start of the connection, as you can see, our technology started at about 770 kbyte per second, and about 5% has been uploaded in a very few seconds, while Google BBR is 32.1 kbyte per second and 0.09% has been uploaded, and Cubic is 13 kbyte per second and 0.04 or 0.10% has been uploaded. The file size we are uploading is 585.2 megabyte per second. So the adaptive nature of our groundbreaking congestion control technology maximizes network efficiency. First, it's a server-side only implementation which doesn't require client modifications at all, and it's a drop-in replacement for existing solutions. Some of the key innovations in our technology is its adaptive round-trip time evaluation, which is dynamically adjusting network delay, real-time bandwidth estimation. It means that it's a very precise congestion control and proactive nature of congestion avoidance. It's predictive to congestion and bandwidth memory factor optimized throughput balancing. Now the key innovations of our technology makes it adaptive to the network. It adjusts parameters. The rate at the beginning of the connection might not be the best rate, but once parameters are set and it knows exactly if it's dealing with congestion or bad connections, it adjusts parameters and the rate improves with time. Now the speed is our technology around 687 or 690 kbyte per second, and already 21% has been uploaded, while Google BBR is still crawling 15.6 kbyte per second and 0.44% has been uploaded, and Cubic is a slightly better than Google BBR, 37.2 kbyte per second and about 1% has been uploaded. So Google BBR and Cubic are very comparable. They both has their own drawbacks. Google BBR used to give a slight edge over Cubic in regards to bad connection, as it differentiates between congestion and bad connections. But with recent upgrades to Cubic, it makes it better, even better than Google BBR in performance overall. So Google BBR, one of its drawbacks, it doesn't coexist well with other algorithms. It reduce performance and underperform when coexisting with other algorithms. For example, if a network has bunch of users and every user is using a congestion control algorithm. In this case, Google BBR used to downgrade the performance. While Cubic is better than Google BBR in this context, it still has an issue, which is the round trip time really fluctuate over time. So it's not best for real-time applications. Unlike our technology, which does coexist very well with other algorithms, and bandwidth sharing is very smooth and great at our technology, and at the same time the round trip time is very stable and smooth. You can see the round trip time graph shows our technology is very flat in the test benchmarks we conducted over the simulator and real world scenarios. Now our technology reduced speed a little bit to it might be due to congestion, or it might still adjust parameters. So the rate is around 535 kbyte per second, and already 32.26% has been uploaded, while Google BBR is 30.1 kbyte per second and 1.90% has been uploaded, and Cubic reached 119.7 kbyte per second, but still around 7% has been uploaded, very slow. Both technologies state of the art, which makes up the huge market today, are very slow compared to our technology. So our adaptive mechanisms and nature of our technology makes it better for improving the range of coverage for a network. For example, we all see that using the congestion control algorithm, which is part of the protocol that makes up the HTTP protocol, which is used normally for TCP connections on today internet. If someone goes under a tunnel or goes under a bridge or goes in a remote area where coverage is poor, the internet is affected greatly, and we see that very slow connection happens, and video lags happens, all sorts of frustrations happen. With our technology, we guarantee that this is not the case anymore. Whether someone going under a tunnel or going in a remote area under unstable conditions and unstable network conditions, we guarantee that the performance of the network would be still very greatly efficient and high rate. As you can see, we are connected to Wi-Fi, and the connection is very poor. We are away from the Wi-Fi, although although this and coexisting with other algorithms, our performance is around 620 kbyte per second, and 53% has been uploaded in about 10 minutes, while Google BBR is still 3.32% has been uploaded and 38.6 kbyte per second, while Cubic is slightly better than Google BBR, which makes 110 kbyte per second, and around 9.5% has been uploaded. So our technology, the design of our technology, which consists of the mentioned points, which is adaptive round trip time evaluation, real-time bandwidth estimation, bandwidth memory factor, and proactive congestion avoidance, makes it very adaptive to the network and adjust parameter as the connection progress throughout the life of a connection, so the rate would improve with time. We will see that the rate will improve with time, and as the connection takes time living, the rate would improve with time. Now the rate is 610 kbyte per second, and around 63% has been uploaded, while Google BBR slightly improved to 39.6 kbyte per second, but still the uploaded is 3.88 or 3.9%, and Google and Cubic is 115.9 kbyte per second, slightly better, but didn't progress in sending a lot. It recalculates and still. So when the connection is still, it's facing a challenging network condition. So it's like thinking what should be the rate should be, and it doesn't send or progress. So although the rate is still 113 kbyte per second for Cubic, it's very slow in progressing. About only 12% has been uploaded, and Google BBR 38 kbyte per second, and only 4% has been uploaded. So we can see that Google BBR and Cubic are crawling in comparison to our technology. Now the rate improved. Our technology now 660 kbyte per second, and around 78% has been uploaded. We will see how long it's gonna reach, but because the file is only 585.2 megabyte per second, we might not see the full potential of our technology in comparison to other technologies. As mentioned before, it improves with time due to the adaptive nature. So if the file were bigger, the difference, the gap between our technology and other technologies, state-of-the-art algorithm used today like Google BBR and Cubic, will be even greater. So now the speed is around 680 kbyte per second, and around 86 or 87% has been uploaded, while Google BBR is still 36.2 kbyte per second, and only 4.29% has been uploaded. Cubic decreased to 99 kbyte per second, and 12.24% has been uploaded. Okay, so let's recap. Our technology now is over 700 kbyte per second, and around 93% has been uploaded, as you can see. while cubic is 99 kbyte per second, 12.24% has been uploaded, and Google BBR is 34 kbyte per second and 4.57% has been uploaded. Thank you very much. This was Muhammad Afifi from ConexTech.